Here we're going to be talking about solving literal equations. A literal equation is just an equation that involves two or more variables. So instead of just having one variable, we're going to have more than one letter in there, just like you see over here. Those are some examples. And you're going to pick out the variable that you have to solve for and try to isolate that one variable by basically using the exact same steps that we've been talking about. It's just that now we have more than one variable, so it looks a lot trickier, but really you're treating every other variable just as a number and undoing those operations, just like we've been doing with simple multi-step equations. So our first thing is just identifying the variable that we're solving for. We're just going to pick out whichever one we're actually solving for and think about what operations actually happen to it. Then we treat all other variables as numbers. And to undo those operations, we use inverse operations. We use the opposite operation. To get rid of those other variables. And instead of getting a number, like x equals 10, we're going to get an expression as our answer. So it's going to be something like x equals y minus x. Well, not another x. That was silly. Y minus k divided by w. Instead of getting a number, we'll have an expression. But again, to get that expression, we're using the exact same steps as to solve a just normal multi-step equation. So in that first example, we're trying to solve for w. We want to get w completely by itself. We really want to think about what is happening to that w. Right now, it's being multiplied by L. To cancel that out, we're going to use the inverse operation, which is just using division. We're going to divide both sides by L. If you multiply by L on one side, to cancel that out, you divide by L, and if you divide by L on one side, you have to divide by L on the other. On the right side, those are just going to completely cancel out. We're left with w equals a over L. A lot of times they're going to put the variable on the left side of the equal sign, like w equals a over L, like that. Either of those are perfectly okay as long as you have your w completely by itself. On the second example, we're trying to solve for L. So you really want to think about what is happening to the L right now. It's being multiplied by 2, and we're adding a 2w to that. You don't have to write this part down, but I just want to show you that we can treat everything else as a number. I'm going to pretend that p is just a number of 100. 2l actually is okay. I'm going to keep L as a variable, because that's the important one right now. Plus 2w, let's just call that 40. If I wanted to solve for L, I would first subtract away that 40. That's exactly the same first step. Instead of having numbers and being able to just subtract 100 minus 40, I'm going to subtract away the 2w minus 2w on both sides. On the right side, it completely cancels out a positive 2w, and a negative 2w completely cancels out. All I have left is that one term of 2l. And that equals, it's a little bit different from the number example. In the number example, I would get 60 equals 2l. With these letters, those aren't like terms. I'm not allowed to combine those. I can't somehow combine a p and a w. It's comparing apples and oranges. I'm not allowed to combine those, but I can write that as an expression. I'm going to write it exactly like I see it there. P minus 2w. And then I'm going to follow that same kind of pattern here. Exactly what I would do there. I would divide by 2. Oops, I would divide by 2 and divide by 2. This gives me an answer. My literal equation is going to be a little bit different. I can't actually simplify that. I'm going to divide by 2 on the right side. That can simplify. That cancels out. And I'm left with an expression on the right side. The entire thing gets divided by 2. The entire left side, p minus 2w, is all over 2. And that's my final answer. Actually, I'm going to rewrite that. again with my variable on the left side of the equation. L equals P minus 2W. All of that is over 2. You can do exactly what I did on that problem, where you basically change all the other variables just into a number. And then you think about how would you actually solve that equation. That was only a 2-step equation. It really wasn't a complicated equation. It just looks complicated because there's 3 variables in there. And the answer doesn't really look that simple either. But that's as simple as we can make that without knowing the values of the P and the W. On the third example, we're trying to solve for H. There's plenty of ways you can do this. The way I'm going to start is by canceling out the multiplying by 1/2. So multiplying by 1/2, you can do that in 2 different ways. You can divide by the 1/2, or you can multiply it by the reciprocal. I'm going to do that just because it makes my answer later a little bit simpler. I'm trying to cancel out that 1/2, so I'm going to multiply by the reciprocal, which is basically just multiplying by 2. 2 over 1 and 2 are the same thing. On the right side, it's going to cancel out. Leaves me with B times H on the right side. And on the left side, I'm going to actually simplify that. I'm not going to consider this a fraction right now. I'm just going to multiply by 2. Which leaves me with 2 times A, or just 2A. All right, one more step. I want to get H completely by itself. I'm going to cancel out some multiplication. So I'm going to use division. I'm going to divide by B. It cancels out on the right side. That leaves me with just H. And on the left side, I'm left with this expression. I'm flipping my equation around here. But it's still just that expression, 2A over B. On the fourth example, I want to get P by itself. I'm trying to solve for P. Let's actually substitute some numbers in there. Let's say 100 again, and P times, let's call that a 2 and a 5. I'm really just making up random numbers. It really doesn't matter. If I'm trying to solve that equation, the first thing I would really do is simplify the right side. I know I can actually just multiply some of this stuff together. So I'm going to change that into 10. P. The 2 times 5 combined to just 10. So I can't really do that there. R times T is written as simple as it gets. That's just R times T. But I know that that's eventually going to combine to one thing, which I can divide away. Using that exact same idea in this first step, I'm going to divide the entire thing away in one shot. Instead of dividing by R and then dividing by T, I can divide by the entire product there, just like I'm doing here. I'm dividing by 10. I'm going to divide by the whole product of RT. On the right side, it goes away. Multiplication and division basically just cancel out there. And that leaves me with P equals I divided by RT. Once your variable is by itself, you know you're done. P is completely isolated. In the fifth example, I'm trying to solve for B. This is similar. I know that mx is just one thing, really. I don't need to separate that at all. I don't need to somehow get rid of the m and then the x. I just want to get rid of that entire thing in one second. I know the entire thing is being added to B right now. If the entire thing is being added to a B, I could basically just subtract that entire thing on one step. I'm going to do minus mx on both sides. Another way to say that is that's a positive mx. I'm trying to cancel that out, so I use a negative mx. Even another way to see it, you can think of this as y equals b plus mx. To cancel that out, you just subtract mx on both sides. Those are the exact same expression. The original one here and that one are identical. So I'm subtracting mx, it cancels out on the right side. On the left side, I just write this as an expression. Y minus mx equals b. And that tells me I'm done. Once the variable that I'm interested in is completely by itself. Now I'm solving for x in the exact same equation. The reason we're bringing this up twice is that's an important equation. That's the slope-intercept form of an equation. And it's actually something that we are interested in solving for different variables. I'm going to use numbers for my variables on this one just to show you the steps. I'm going to use 100. It's a nice even number that's divisible by a bunch of things. And then 5x plus 25. So all I did was substitute in numbers for every other variable in the equation, and it's just a two-step equation. Follow the exact same steps as you would. Minus 25, minus 25, that cancels out, that gives us 75, then 5x is multiplication, so I use division to cancel that out. X would equal 15. I'm using the exact same steps there. It's not going to give me a nice number like that one, but I can use these exact same steps, subtraction and division. I'm going to subtract away the thing that's being added, minus b. That gives me y minus b. Again, I can't really simplify that because a y and a b are different variables. I don't know what those numbers are yet, so all I can really do is just write that as a difference of those two things. That equals mx. And then I divide away the m. Make sure you divide the entire left side by that variable. It's not just one part of that. The entire side here is getting divided, so the entire side here needs to get divided. That cancels out, and that's my expression. X equals, I just like the variable on the left side, so I'm going to switch that around. X equals y minus b all over m. Alright, I'm going to do a few more of these with you just because there's some special examples. I think you can handle that first one, so you're going to try that one on your own. You do this one. I am going to do this one, where we have to solve for a in the Pythagorean theorem. So I want to get a by itself. I want to cancel out something that's being added to a. And I have an exponent on it. That's something that we actually haven't dealt with yet. But it's really just thinking about inverse operations. It's really just one extra step. So I want to cancel out the adding b squared. I'm going to subtract the entire b squared from both sides. Minus b squared. I don't know what c squared is. I don't know what b squared is. But I can just write that as a term in my expression. A squared equals c squared minus b squared. Make sure you write it in that order, or at least with those signs. It's a negative b squared and a positive c squared, so I'm writing it in that order. Remember, we could change the order. I don't know really why you want to, but you could write this as a squared equals negative b squared plus c squared. Those are really the exact same thing. Then I have to cancel out squaring something. So if I think about 4 squared, that's 16. If I wanted to get back to 4, the opposite of that is taking the square root of 16. You take the square root of this thing, and it gets you back to the original. So all I really need to do is square root that, and the square root symbol and the squaring cancel out, and it just leaves me with 4 using the exact same idea. I'm just square rooting the left side and the right side, the entire right side. Leaves me with a equals the square root of c squared minus b squared. And I'm going to do a few more with you. I'm trying to solve for r in, what's the volume of a sphere, I think. So I'm trying to get r by itself. Again, you really want to think about order of operations backwards. You're trying to cancel out an exponent and some multiplication. So you have to cancel out, you're really doing this backwards of order of operations, so you have to cancel the multiplication first. I'm going to deal with that fraction first, just like I did on the front. I'm going to use the reciprocal. I'm going to multiply by 3/4. It's going to cancel out with 4/3. That leaves me with 3/4 times v. I'm actually going to bring the v up to the top of that fraction. 3 times v over 4 equals pi r cubed. Now I have multiplication times pi, so I'm going to divide by pi on both sides. When I divide by pi on both sides, you could show that as a big fraction, like a fraction over a fraction, but I don't really want to see it like that. If I were to divide this fraction by pi, it's the exact same thing as that's supposed to be pi. It's the exact same thing as just putting that in the bottom of the fraction. So I can just rewrite this into the bottom, and I'm still dividing that expression by a pi. So 3v over 4 pi equals r cubed. I'm going to finish this the same way I just finished the Pythagorean theorem one. I want to do the opposite of cubing something. The cube root will cancel out cubing something. Those are opposite inverse operations, so they just cancel out, leaves me with just r, which is exactly what I want. I'm going to do the cube root on that side, and the cube root on this side also. That leaves me with r equals the cube root of 3v over 4 pi. That's probably the trickiest example you'll see. I'm going to do 2 more for you. We have an expression with a k, an m, p, and a distributive property. You can do this in a couple different ways. Again, there's options on these, but I'm going to distribute that 5 into both terms. I'm usually going to distribute that just because it's a little bit simpler to see your answer at the end. So my first step is actually making this a little bit more complicated. I'm actually attaching something to the k. Even though I want to get the k by itself, I'm actually going to add something to the k. Which, well, really I'm multiplying something by the k. It becomes 5k minus 10m equals p. All I did was distribute the 5 into the parentheses. Then I'm going to follow the exact same steps as before. I'm trying to cancel out whatever's being subtracted first, and then I'll deal with this multiplication. So I'm going to add 10m, add 10m. That gives me 5k equals p plus 10m. And now I want to cancel out multiplication by using division. So k equals p plus 10m all over 5. There's another way to do this. If you think this is simpler, actually I'm going to show it to you. If you think this is simpler, you can use this. Really, it's up to you whichever way you want to see it, because these are equivalent expressions. But you don't have to distribute that 5. If you think about order of operations backwards, you would do inside the parentheses first, and then you would do that multiplication. So we'd cancel out that multiplication first. Cancel out this times 5 as your first step. You can divide this entire side by 5, and divide that entire side by 5. You'd end up with k equals, k minus 2m equals p over 5. Actually, this is less steps. This is just going to end up being 2 steps. I'm going to add the 2m to both sides. That leaves me with k equals p over 5 plus 2m. Might not look like it, but those are actually the exact same expression. I would accept either one of those on a test. I think you can handle the rest of these on your own. I'm going to ask you to finish the 5, really 6 that we didn't do. The one at the top, plus these last 5 at the bottom. Try your best. You can always email me with questions if you have anything. Email me right now while you're doing this in class, or over the weekend while you're finishing this up. Email me with questions. I'd be happy to explain anything you need.